Alright, this is part 2 of our review, and better added into the title. Review C part 2. That's why it's starting with number 5. So if you didn't watch the first half of the review, definitely go back and watch that now. Alright, also the day 5 homework video would be a good review. Make sure you check that out. Alright, let's get started. An airline finds that travel time between two cities has a mean of 85 and a standard deviation of 7. Find the z-score for a travel time of 75 minutes. Well, my friends, we have a formula for z-score, and that's what we're about to use. The formula for z-score is the z-score is the value minus the mean divided by the standard deviation. So in this case, the z-score is going to equal 75 minus the mean, and they said the mean was 85. So 75 minus 85 divided by the standard deviation, which was 7. Okay, so put that in your calculator and smoke it. Alright, I'm getting negative 1.42857. Of course, for z-score, we're going to definitely cut this off as 2 decimal places. We will round properly, so since this next number is an 8, this is going to have to round up to a 3. Okay, so negative 1.43. Alright, what's next? Find the z-score for a travel time of 90 minutes. Okay, well, similarly, the z-score is going to be 90 minus 85 divided by 7. That's going to be 0.714286. We're going to cut it there. Since this is less than 5, I'm just going to leave it 71. Okay, so there you go. What does this tell you about the 2 flights above? Well, okay, let me read. What is this problem about? An airline finds that the travel time between 2 cities has a mean of this and a standard deviation of that. Okay. Looking at that first one with the 75 minutes, it's telling me that a travel time of 75 minutes is almost okay, it's almost 1.5 standard deviations below the mean. Okay, so 90 minutes, travel time of 75 minutes is significantly below average, you could say. On the other hand, with the z-score, from the 90 we got this 0.71. That's almost 1 standard deviation above the mean. So a 90-minute travel time is significantly above average. It's almost a standard deviation above the mean. Alright, so something like that is good. I guess we could have been real specific and said a travel time of 75 minutes is, I could have said 1.43 standard deviations below the mean, and I could have said a travel time of 90 minutes is, why does that say as? Instead of saying almost 1 standard deviation, I could have said is 0.71 standard deviations above the mean. Alright, if you want to be precise, then that's how you would say it. Alright, anyway, find the travel time that coincides with a z-score of 3.12. Okay, let's use the formula. So again, using the formula that the z-score is the value minus the mean divided by the standard deviation. if we're given a z-score of 3.12, then that would mean 3.12 is equal to some travel time minus the mean, which was 85, divided by the standard deviation, which was 7. So it's just a matter of solving this little equation for x. You would solve this by multiplying by 7 on both sides. That way these 7s are going to cancel each other out. Okay, so, all right, 7 times 3.12 is 21.84. So you get 21.84 equals x minus 85, and then there's nothing to do but add 85 to both sides. Okay, so that's going to give us 106.84. Okay, is equal to x. So this is the travel time that would correspond with a z-score of 3.12. All right, what's next? Number 6. The distribution of IQ scores for all 7th grade students is approximately normal with a mean of 111 and a standard deviation of 11. Draw an accurate sketch of the distribution and use the empirical rule to answer the following questions. Well, the empirical rule, that's when we know that, the first standard deviation is 34%, all those percentages. So I'm going to cheat and copy a picture from before. Kabam! This is what we're talking about. All right, so let's see, what do they tell us? There's a mean of 111. All right, the mean always goes in the middle of the distribution, so there you go. They told us that the standard deviation is 11. Okay, now each one of these lines represents exactly one standard deviation from the mean. Okay, so for example, I'm just going to add 11 each time. So this will be 122, 133, and 144. Similarly, I will subtract 11 going in this direction. Thank you. So that's going to be 100, and then 89, and then 78. Yeah, just put them in those pockets. Okay, now, the empirical rule basically gives us all those percentages that we are supposed to memorize. For example, this is 34%. Okay, and then this is 13.5%. And this is 2.35%. And last but not least, 0.15%. Okay, if you have not memorized these percentages yet, you are behind the power curve. And you need to get with the program. All right, now we're supposed to use this accurate sketch to answer the following questions. Between what values do the what values do the IQ scores of 95% of 7th grade students lie? Okay, well that's actually another set of numbers we were supposed to memorize. And let me just go through them real quick. You were supposed to memorize that if you go out one standard deviation in both directions, okay, that is 68% of the data, okay, would be in between here. And that's easy because it's 34 plus 8, 34. But what about if you go out 2 standard deviations? Well, if you go out 2 standard deviations and you are here and here, all right, turns out that is your 95% of the population is 2 standard deviations in both directions. if you go 3 standard deviations in both directions, okay, now that's taking you all the way to here. Okay, that's going to capture 99.7% of the data. Okay, so they're asking about 95%, but we know that that's 2 standard deviations in both directions. So we should be looking at this one right here, like I showed you a second ago. All right, from here to here, we have memorized is 95% of the data. So what values you say? Well, that's between 89 and 133. And I could write it as an interval, 89, 133. Or I could write it using an inequality. Okay, I could say the proportion of x's are between 89, so 89 is less than x, which is less than 133. Okay, and that's equal to 95%. Okay, so this is kind of the answer over here on the left. All right, either way, or you could just use words and say 89 to 133. All right, so many ways to do it. Now, what percent of IQ scores for 7th graders are greater than 100? Okay, well, here's 100. Greater than 100 will be to the right. Okay, so look, start with your symbolisms. So we're talking about the proportion of x values that are greater than 100. Okay, so you could just add up all these numbers, but look, if you start from the middle, hold on, if you start from the middle, you know that from here over, that's 50% automatically because it's half, it's to the middle. So I really could just do 50% plus the extra 34. So that's 84%. Okay, great. What percent of IQ scores are between 89 and 144? Okay, well, let's check it out. All right, so let me go back to yellow. Here's 89, and here is 144. Okay, so I could add up all these numbers. That's one way to do it. Or because this is most of the entire picture, I could start from 100 and subtract the 3 bits that are missing. Okay, so all right, so we're talking about the proportion of x values that are between 89 and 144. And I could get this by doing 1 minus these 3 pieces. So 1 minus, well, you know, I guess I'm doing not 1 minus, but 100, because we're dealing with percents right now. So 100% minus 0.15% minus 2.35% minus the other 0.15%. Okay, let's see what's left. All right, we are looking at 97.35%. Okay, moving on. Number 7. The National Collegiate Athletic Association, NCAA, requires Division I athletes to score at least 820 on the combined mathematics and verbal parts of the SAT exam in order to compete in their first college year. Higher scores are required for students with poor high school grades. In 1999, the scores of the millions of students taking the SAT were approximately normal, with a mean of 1017 and a standard deviation of 209. What percent of all students had scores less than 820? Okay. Now, the reason why we're not just using this empirical rule like we did before is because 820 is not going to fall nicely on a standard deviation. 820 is going to turn out to be between the lines. So we're going to need to use our z-score table to find those percentages anytime it's not a nice even standard deviation. And to keep our work organized, we've learned to put it into these 4 boxes. The top 2 boxes are going to be pictures. All right, we're going to start with SAT scores over here and z-scores over here. Here we go. All right, so draw yourself a normal distribution. Drop a line down the middle for the mean. Let's see, they said the mean was 1017, so let's put that down here. And you must label this. So this is SAT scores. So we got the mean. Okay, so they want to know what percent of students had scores less than 820. Now 820 is definitely to the left of this, so I'm just going to put it over here somewhere. Okay, so let's say this is 820. Okay, less than 820, so we're talking about to the left of 820. Okay, now let's put the same information on our z-score chart. Now as far as z-score, the mean is always 0, and let's definitely label this as z-scores. And let's draw that red part as well. So we don't know what this z-score is, so I'm just going to call it z for now. But we still want to know less than, just like before. All right, so we're looking for this percent. So our strategy is first we'll find the z-score, and then we can look up on the chart what percent of the data is to the left of that z-score, because that's what the chart shows us. Okay, so now in this box we'll do our calculations. And the first thing we do is we will convert this 820 into a z-score. Well, as z is going to equal the value minus the mean divided by the standard deviation. So in this case, that's 820 minus 1017 divided by, let's see, the standard deviation was, what did they say, 209. Okay, so I'm just going to put this in my calculator. So I get this. Now z-score has to be cut off at 2 decimals because that's all we have on this chart is up to 2 decimal places. Since this number is less than 5, I leave the 4 alone. All right, if this were 5 or higher, I would have to round up. So I've just turned 820 into a z-score. So that's great. Let's put that negative 0.94 where it belongs. Okay, so that's almost 1 standard deviation less than the mean. Great, now we can use the chart to find out the percentage to the left of this z-score. All right, in the meantime though, let's write our symbols down. So what we're finding then is the proportion of z values that are less than negative 0.94. Okay, that is what we're finding. And that's what the chart delivers. So let's go to a z value of negative 0.94. Okay, so negative 0.9 is right here. Okay, now say 0.90, 1, 2, 3, 4 would be right here. Okay, if you were to scroll up, you could see, yeah, that's the 4. So 0.1736. Okay, again, anytime you're looking at this chart, you're looking at the proportion of the data that's to the left of this z-score. And luckily, that's just what we wanted. All right, we wanted the proportion of data to the left of this z-score. And we just found out that it was 0.1736. Or written as a percentage, this would be 17.36%. And that's going to be the same for both graphs, so I'm just going to put it down. So 17.36% of the data is to the left of 820, and 17.36% of the data is to the left of 0.94. All right, now we can answer the question in a complete sentence, and that's what we do right here. Remember, the question is, what percent of all students had scores less than 820? I like to reflect the question back in my answer and say 17.36% of all students had scores less than 820. Okay? Again, it's a really smart move to take the question and reword it as your answer. All right, just soak that in for a second. All right, now let's move on to part B. All right, we're still dealing with the same scenario. All right, ignore this bit about showing work on other paper. What percent of all students had scores between 800 and 1200? All right, again, we need to draw our graphs next. Okay, so you start off with your basic normal distribution. Of course, the mean goes in the middle. Don't forget to label it SAT scores. This is worth points. Now, between 800 and 1200. Well, 800 is going to be to the left somewhere. All right, so we'll call this 800. And 1200 is going to be somewhere to the right. So we'll just put it over here somewhere. All right, if we want to know what percent of all students had scores between these values, then we're talking about this area under the curve between 800 and 1200. So let's go ahead and just shade that in, people. So that's the area that we are speaking of. Let's go ahead and define a similar area on the z-score chart. Don't forget, 0 will always be in the middle of the z-score, and don't forget to label it as z-scores. So we're going to have a z-score over here and a z-score over here. Now we don't know what these are yet, so I'm going to call them z1 and z2 temporarily. But once again, we are interested in what lies between them. Okay, so that's what we're going to check out. So we have two z-scores we have to find, and we'll just find them one at a time. So z-score number 1 is going to come from the 800. Okay, so let's do that first. Okay, so z-score number 1 is going to equal 800 minus 1017 divided by 209. Okay, so z-score number 1, so I'm getting that z1 is negative 1.04. Notice this was 1.038, but I rounded it to 0.4. Let's do the same thing with z2. All right, now z2 is going to come from the 1200. So we're doing 1200 minus 1017 divided by 209. Okay, let's see what that is. All right, I'm coming up with 0.88. Again, this was 875, so I had to round this up to an 8. Okay, now let's put both of these z-scores on the z-score picture. So negative 1.04 and positive 0.88. All right, so those are the z-scores I'm dealing with. Okay, now if I want to find out the proportion that is between two z-scores like this, all right, using the chart. Remember, these chart values only give me the area to the left of each value. So really, if I look up these z-scores on the chart, it's going to give me the area to the left of the 104, the negative 104, and this whole entire area to the left of 0.88. But turns out if I want just the overlapping part here, then I need to subtract. I need to do the big percentage minus the smaller one. So just be ready to subtract. So I am going to find the proportions off the table. So what I'm looking for is the proportion of z values that are between these two. So that's negative 1.04 is less than z, which is less than 0.88. Okay, you must show your symbolism here. Okay, now it's going to be the big proportion minus the small proportion that I'm about to find off the chart. So I'm going to start with the 0.88 is positive, so I need to skedaddle over to the positive side. So here's 0.8, and this is 0.80, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's 0.8106. Now, this is going to be minus the proportion I get from the lesser z-score, negative 1.04. So I need to get over to negative 1. So here's negative 1. Whoops, no, that's not negative 1. Here's negative 1.0. Okay, so this is where I should be starting off. Let me get rid of this old stuff. Negative 1.04. So this is negative 1.00. 1, 2, 3, 4. So this is the number we want. 0.1492. All right, and if I subtract, that's going to give me the proportion between the z-scores. That's giving me 0.6614, which as a percentage would be 66.14%. So that is the percentage that's in between these two z-scores. So let's go ahead and write that down. Okay, whoa, I missed. Okay, what did I say? 66.14% is in between there. And that should be the same for the SAT scores as well. So 66.14%. Time for the complete sentence. What percent of students had scores between this and this? Well, it turns out that 66.14% of all students had scores between the two values you said, 800 and 1200. All right, and that is it. Here's the big picture. Soak in what just happened. All right, let's roll on to part C here. What percent of all students have scores greater than 1400? All right, so of course we start off with our basic normal distribution with the mean and the label. Greater than 1400 will, okay, let's just say 1400 is over here somewhere. All right, greater than 1400 would be shading to the right. Okay, now we'll have to be careful because when we get to this z-score chart in a little while, please remember the z-score is always to the left. So we're going to have to do something to compensate for that. You know, we have a couple options, but we're not going to be able to just take the value right off the chart. Anyway, speaking of z-scores, let's get that graph going. Of course, we got a 0 in the middle, the label, similar shading over here. We don't know what this z value is, but we know whatever it is, we are interested to the part to the right. Okay. So, the next thing we do is find this z-score, all right, using our little formula. So, let's get down to business and do that. So, the z-score is going to equal our value minus the mean divided by the standard deviation. Okay, so fine and dandy. This is going to be, so the z-score is 1.83. So let's go ahead and put that in the picture now. So we know this is 1.83. Now please understand, if I look this z-score up on the chart, it's going to give me the percentage to the left. That's all the chart does, is give me to the left. That's fine, but I will either have to subtract the percentage from 100 or subtract the decimal from 1 if I want to find the part on the right. So fine, let's go ahead and look up this z-score and see what it says. But don't forget that what we want, and let's show our symbols, we want the proportion of z values that are greater than 1.83. Okay, that's what we want. Now, the chart gives us the proportion of z values that are less than 1.83. Okay, that's all the chart does is less than. But that's not what we want. So anyway, let's check it out. 1.83, so that'll be on the positive side. Okay, so here's 1.8. So 1.80, 1, 2, 3. So that's 0.9664. Okay, so the chart is saying 0.9664. Okay, now this is to the left. All right, this is the proportion of z values that are below 1.83. If I want the proportion of z values that are above 1.83, okay, so far we've got the below part, this whole white area. In other words, you know, percentages are easy to understand. See this 0.966? You understand that this is 96.64%, right? Okay, so what they're saying is this white area is 96.64% of the graph. Okay, that's what the chart tells us. So if I want the red part, couldn't I just subtract from 100? So if I do 100% minus 96.64%, shouldn't that give me the red part? Okay, so let's quit out of there. Okay, so 100 minus 96.64. Okay, so that's 3.36%. So that's what this must be, 3.36%. All right, it's what you get left over if you take the whole thing, 100%, minus the part on the left. Okay, so that's one way to do it, is to take your percentage on the left and then subtract from 100. Or you could have done it this way, and you could just deal with the decimal. If the proportion to the left of 1.83 is 0.9664, then the proportion to the right, greater than, will be 1 minus 0.9664. And of course, that's going to give us 0.0336, which again, moving the decimal over to make a percent, is 3.36%. All right, which is what we got the other way too. So there's two ways to think about it. You do it whichever way you feel most comfortable with. All right, anyway, so the percent of all students, the question is, what percent of all students had scores greater than 1400? And now we just found out the answer, 3.36% of all students had scores greater than 1400. All right, that's all she wrote. All right, so there's an overall view of what just went down. Check it out. All right, last problem, correct? Yeah, this is the last problem on this video. Let's see. It is possible to score higher than 800 on either part of the SAT. But scores above 800 are reported as 800. That is, a student can get a reported score of 800 without a perfect test. In 1999, the scores of men on the math part of the SAT followed a normal distribution with a mean of 531 and a standard deviation of 115. What scores make up the top 2.5% of male math scores? Okay, we're only talking about men. Interesting. Anyway, let me draw your attention to something. They're asking us for the scores. They're giving us the percent. That's the opposite of what we've been doing so far. Up until now, they've been saying what percent? What percent? What percent? Okay, they've been giving us the scores and asking us the percent. Now they're giving us the percent and asking us for the scores. So be prepared for things to happen just a little bit differently. Well, it starts off same as always. Make a normal distribution. We got SAT math scores, got to label it. The mean goes here. What did they say that was? I'll just talk about 800, but the mean was 531. All right, so that's going to go right here in the middle. All right, 531. So we've got that. Now, they are giving us the percent. So what scores make up the top 2.5%? Okay, this is actually going to fall right on one of the standard deviations. So I could have done the empirical rule this time, but let's go ahead and do it using the z-score table, because there's no guarantee that's going to fall right on a standard deviation like this one happens to. Anyway, you probably wouldn't have even noticed if I didn't say anything. Okay, so let's drop a line right about here. The top 2.5%, that's why I'm hanging out over here, all right, at the high end, all right, not over here at the low end, top 2.5%. So I don't know what this number is yet, so I'm just going to call it X. But what I do know is this red area here is 2.5% of the data. That's what I do know. Now let's get over to the z-score graph. Don't forget to label it up. The middle z-score is always 0. Okay, and we have to label this z-scores. All right. Now let's get our 2.5% going. Okay, top 2.5%. So I know that this is 2.5% of the z-scores, but I do not know what this z value is. I'm gonna have to figure that out. Here's the key though. We've got to be super careful. Normally we start with the percentage, we turn that into a decimal, and then we look it up on this chart. Get rid of some of this yellow stuff. The problem is this chart is only proportions that are to the left of the z, only to the left. Okay, whereas this is to the right. So how am I going to match up a right percent with the correct z-score? Yeah, you can't do it. So what you need to do is ignore this 2.5% and look at the left part of the picture, the part that's all in white. All right, because everything to the left of the z-score, that's the percentage that I need to find my z-score. It's not easy to figure, I'm sorry, it's not difficult to figure out, right? You know the entire distribution is 100%. So doesn't it make sense to you that if I do 100% minus 2.5%, that's going to give me the left part of the distribution. So you can probably do this one in your head. This is going to be 97.5%. All right, 97.5% is the left part of the distribution. So even though we want the top 2.5%, we'll worry about that later. It's the 97.5 that you must use. You must use the percentage to the left of the z-score no matter what. Okay, so as I said, we will start with a percentage of 97.5%. As a decimal, that is equal to 0.975. All right, to make it match the decimals on this paper, I'm going to give it an extra 0, so it'll be the right length. So I am going to look for the closest thing I can find to 0.9750, and that will tell me the right z-score to use. 0.9750. Okay, 0.973. Whoa, 0.9750. It's exactly right there. Sometimes it's not exactly there, and you have to get the closest thing you can. But this time, I think I mentioned that it's going to be right on the standard deviation. So that's what I meant. So 0.9750. That's going to translate to a z-score of negative, of 1.9. 1.9 what? 1.96. Okay, 1.96. So normally we have something that's close, and we'll say 0.9750 is closest. Now I could have skipped this because it's the same exact thing. Is it really 0.9750? Yeah, there it is. But anyway, that gives us our z-score of 1.96. Fine, so we found the z-score. Let's put that in the picture. 1.96. Yeah, that is almost 2 standard deviations over. 2 standard deviations above the mean. Anyway, what we really want is this x value, all right, the SAT math scores. But what we have is a z-score, so we're going to use this z-score to do the calculations. We're going to turn this z-score into an x value, an SAT score. Using the formula, we know that the z-score is going to equal the value minus the mean divided by the standard deviation. But I know the z-score is 1.96, so this becomes 1.96 is equal to x minus 531 divided by, now what was that standard deviation again? 115. All right, all right, all right. Okay, so it's just a matter of solving this for x. Easy enough. We'll multiply both sides by 115. That way these will cancel out. So that gives us this. Then we shall add 531 to both sides. So x is 756.4. All right, at this point we can go ahead and answer the question. Okay, I'd like to put this on the picture though. All right, this is 756.4. So the question was, what scores make up the top 2.5% of male math scores? So I'm going to start off by reflecting the question as part of my answer. And I will say the top 2.5% of male math SAT scores are above, and let's see, they're above 756.4. All right, and that was the last question of this lesson. I hope this video was helpful, and I will see you on the next video. Check it out.